use synthetic division. And let's take a look at the notes for that. For synthetic division, we have a polynomial such as ax to the n plus b, and then this means one exponent lower, next exponent lower, until you get x plus some constant. Where you're dividing by x minus c. So in your synthetic division, you're going to be using the opposite sign of what you have here for this x minus. So you determine what c is for your divisor, use only coefficients in the polynomial by bringing down the first term. Okay, we multiply our divisor times the next term down. And we place it in the second row. And then we add the terms in the first and second rows and repeat, keep going on down the line until we replace all the variables. The leading variable is 1 degree less than the dividend. So let's see what that looks like. In our synthetic division, here we have x squared minus 5x plus 4. And we divide that by x minus 1. So in our synthetic division, you could set it equal to 0. So your c value is going to be 1. So you put 1 there. You're going to put the opposite sign of what the x minus number value you have for there. So now we're going to, again, you need to have a place for the x squares, you need a place for the x, you need a place for the constants. So you only need places for the highest, whatever your highest exponent is. And what we're going to do is we're going to look at the coefficients for each one. Okay, and so we're going to put in a 1 for 1x squared, and then we're going to put in a minus 5 for minus 5x, and then we're going to put in a 4. Draw a line, and we're going to bring down that first term. So that's going to be a 1. And now we're going to multiply 1 times 1 is 1, and we're going to bring that over to the next row. Now, depending on whether your signs are plus or minus, depends whether you're going to add or subtract. So we got minus 5 and plus 1, that'll be a minus 4. And so now we multiply 1 times negative 4, and we get a negative 4. And so now we have a positive 4 and a negative 4 that goes to 0. So we can say that our quotient for this division problem is going to be, we look at what we have for our quotient and we go 1 lower than what our exponent is. So our leading exponent is going to be just x to the first, because this is a 1 here, and then minus 4. And our remainder is 0. And that's our answer. Okay. Let's try a different problem. And here we have x cubed minus 27, and that's over x minus 3. Okay, so our divisor is going to be 3. The opposite for x minus 3. And again, we need a place for each value, place value for our polynomial. Even if it has it or not, we need a place for it. And so x cubed, that has a coefficient of 1, right? So we're going to put a 1 there. But there's no x squares here, so we're going to put a 0 for x squared. And there's no value for x, so we're going to put a 0 for that coefficient. and then we have a minus 27 for our constant. So we draw our line, and we bring down the first term. And that's going to be a 1. And now we're going to multiply 3 times 1 is 3, and we're going to bring that up to the second row. And now we have a 0 plus 3 is going to be 3. And now we multiply 3 times 3, and that's going to be 9. So we put 9 up here in the second row. And so now we have 0 plus 9 is going to be 9. Now we're going to multiply 3 times 9, and we get 27. So we're going to bring up 27 here. We've got negative 27 and positive 27, that'll be 0. So we can say that since our leading exponent started off with as an x cubed, that we're going to start off with a 1 x squared, and then we have a positive 3, so that'll be plus 3x, and then we have a positive 9, so that'll be plus 9, and we have a remainder 0. And that's our quotient and our remainder. Okay, for this next one, we're going to look at what if we need a quotient and we need to use the remainder theorem. So if we wanted to check using the remainder, what we could do, the remainder theorem basically states that P of C equals to our remainder out. So if we were to plug in P of, in this case, C would be 3 into our polynomial minus 27, we should get 0 out. Well, 3 cubed is 27, 27 minus 7, 27 is 0. And so it checks. So the remainder theorem can be used as a check. And that concludes this lesson.